G'day, Bruce here, Barking Dog Bim. If you're just joining us, we are up to part 15 on a series of creating a fully custom door in Archicad using GDL. We've covered quite a bit so far, and what we're going to look at today is what's involved in creating the hole in your wall for your plan view. Believe it or not, this is done using the Wallhole 2 command. When placing a door, you need to account for the 8 different placement methods, the wall thickness, and the reveal depth. I'll show you how to do that. We've got our wall hole here, which is automatically cut by Archicad. Quite often that's enough. Just a rectangular opening in your 2D, and you can control the contours by this default parameter here. 0, none, 1 full, and as you see there, 1 is full. Get the left and right sides. If I raise my door up, that's not sitting right down to the base of the wall, I get my threshold lines in there as well. That's what the full refers to. Now, if that's all you need, that's good. But what I like to do, put this parameter down in my 2D, and of course indent it, and then give it a values. In this case, a values 2 for AC wall contours, with the values and descriptions as you see there. That way a user can choose from a list and not just have inconvenient numbers to type in. That's that one. So now when I check out my object, I've got my wall contours here. Good. In our particular situation though, we need our wall hole to be bigger on one or both sides, or none, depending on the geometry of our door. Remembering if these side frame thickenings go through our cut plane, our view cut plane, then our wall hole will need to widen to suit, because we can't have the frame going in the wall like that. So that's where the wall hole command comes into it. You'll find Wallhole under miscellaneous, doors and windows. And in our particular instance, we want it under the 2D related challenges and Wallhole. You can also find this with a search, find it in the table of contents, and these are hyperlinked in the PDF version. Wallhole 2. If we look at our Wallhole command, we've got N, and we know by now that N stands for our number of coordinate lines. Fill control, fill pen, fill background pen. Well, we understand fill pen and background pen. Fill origin X, Y, and angle. Well, we talked about those with our prism underscore B2 command, so we know what they mean. What does fill control mean? We go down. We see that fill control, right, it's very similar structure as our prism commands and our poly2 commands. Series of flags with numbers associated with those flags, and each one does a particular thing. And we can see that it says that here, the parameterization of the command is mainly the same as the poly2b2 command. Where would be a good place to put that? Well, we can put it up here. We've set our frame width left and right. And if you recall, the frame outline that we're drawing underneath makes use of these already. It only draws to the extent as required by the frame. So we can utilize this same script for our wall hole. Let's copy it up into place. For the fill control, I like to do 2 plus 16 plus 32. And what is that? 2 is draw the cover fill. That's nice and easy. 16 is J5, and the local fill should align with the wall direction. Usually you're just using a masking fill for this, so that's a nice one to put in. And 32 is J6, and the fill is a cut fill. And that's important when you start getting into graphic overrides that affect a cut fill versus a cover fill. Then we've got our fill pen. I'll just make it pen 1. And the reason for that is we're using an empty fill. If you remember, we've defined an empty fill, background fill. And our background pen, we should create one. And if you want to match the Graphisoft parameter, that's the name. GS Wallhole Pen BG for background. And I'll just set it as window background. I'll point out that the Graphisoft door has 3 parameters for this: Wallhole fill, so you get to choose your fill type, Wallhole pen foreground, and Wallhole pen background. And the reason for that is that they need to allow that flexibility to their users across the world. You may choose to do that, you may choose not to. So here we've got these 3 parameters in the Graphisoft doors. And you can see the impact of those parameter settings in the door. Now, in my particular case, I'm only ever going to use this as a background fill for this door. So this is why I've only limited it to 1 parameter. And I've set the empty fill to use as the masking fill. So it's up to you how you wish to handle it. That's our background pen. Then we've got our fill origin, just be 0s. And now we've got our coordinates for our Wallhole opening. Let's save that and see what happens here. Interesting. The automatic Wallhole that's cut by Archicad has gone, replaced with my Wallhole. Looks like nothing's happened. Looks like there's no hole cut at all. If I change this reveal to 100, what we'll find is that there's a Wallhole cut in 2D, but it perfectly coincides with the frame that I've cut because I've used the same coordinates. So I need to cut a Wallhole that's the thickness of the wall, starting at the front of the wall and going to the back of the wall. So my left and my right coordinates in my x-axis are good. It's my y coordinates that I need to sort out. All right, we'll put this back to the front of the wall. What we want to do here, so this is our x coordinate, and that's working right. This is our y coordinate. So instead of going minus GS frame thick, which is the distance from there to there, what we want to do is utilize a global variable that's called wall thickness. That will return the thickness of the wall in which the door is placed. So I've just changed the 1 so I can show you how it works. Look at that. Let's come down to the door thickness. Fairly good. And to show you where you can find that in the help, it's under miscellaneous, global variables, wall parameters. And we've got our various global variables that we can call on for our wall here. Quite a few of them. Quite a few of them. But the one we're interested in is wall thickness. That looks pretty good, right? But it's a problem when you utilize the reveal. It's not cutting my wall properly. And if I put in a line, just so we can see the extent of this, because if it's not cutting a wall, we can't see where it's going to. Just put in a temporary line. So it's still cutting the wall with the correct thickness wall hole, but it's starting in the wrong place. Well, it's starting in the right place according to what it thinks, but wrong place for our needs. So we need to allow for that reveal. This can get a little confusing. So what I've done to help understand the problem, I've created 8 additional doors with each of the 8 placement methods. That would be these 8 placement methods. And what we want to test is for global variable widow reveal side. Now, widow reveal side will be 0 if the anchor point of the door and the door swing are matching. So it's on the outside, on the outside. If they're opposite, the anchor point here is on the outside of the wall, but the doors are opening inwards, the widow reveal side will be 1. 1, 0, because the anchor point and the swing is on the same side. So that's what we want to test for. I've also given the background fill opaque color so that we can see what's going on. To make this a bit clearer, I'll put in some temporary text. That returns widow reveal side. We can see the conditions there. And I'll also put in an axis so we can get an understanding of coordinate system orientation. What we want to do is test for widow reveal side. Depending on which condition we have will depend on what transformation we execute. I've just put in the body of my conditional statement. At the moment, I've executed a transformation that does nothing. And after we've executed our Wallhole, we'll delete that transformation. The easy one to do is if it's 0, if it doesn't have a widow reveal side. What I'll also do is add reveal depths to this. I've just given each one of these a different depth. Otherwise, you can end up with a coincidental solution that doesn't actually fit. It's good to test various scenarios. So if our widow reveal side is 0, we want to add this reveal depth. So on this one, it's 100. We want to add up to the wall face and then draw our wall hole. This one, it's 50. So that's nice and easy. The wall hole starts drawing on the anchor side of the door. We want to add that wall hole up to the outside so we get the full depth of the wall. Easy. And that global variable is called widow sill. Done. So that's the zeros taken care of. That was pretty easy. The ones are a little bit harder. We can see here that our wall hole is drawing from the anchor side of the door. We've got a 300 thick wall. Our wall hole is 300 thick. I don't have a snap line on the back, so near enough is good enough to understand what we're doing. But the reveal is to the back face of the door. I've made this frame a little bit thicker. That's 120, 120. What we need to do is we need to add minus frame thick minus reveal depth plus wall thickness to get it up to here. So it was that minus frame thick minus reveal depth and then add the wall thickness. There we go. So now all scenarios cut the wall correctly. Good. But now we've got the issue of our contours not showing. If I raise my door up, those contours show, but my wall cut contours do not. So I actually have to add them in as lines. Some of you might think it has to do with the status code at the end of my coordinate line under my Wallhole, but it makes no difference whether these are 1 or 0. Not that I can see. Nothing. We'll stop there. Now you have a basic understanding of how to use the Wallhole in your plan views, how to respond to the 8 different placement methods, how to cater for the wall thickness and the reveal depth. We now need to deal with the wall contour lines and how to get them to use the pen of the wall itself. That's coming up. I'll see you there.